Hello friends, I'll be providing you the solution for the microcontroller VTU June-July 2024 examination question paper. So this will be in the three different sessions. In the first session, I'll be covering the module 1 and 2 solution, and in the upcoming, I'll be solving for the remaining. Let us start with the module 1. So here is the module 1 we are starting with. So the first question of the examination, previous examination. So bring out the difference between microprocessor and microcontroller. This is for 6 marks. So there are so many differences that you can make it out. I have listed all of them. So among these differences, at least you must mention 6 differences, so that each difference can carry 1 marks. If you make it at least one additional, that is 7 differences, then that will be much better. So you can just go through all these differences. 1b, with a neat architecture diagram, explain the architectural features of 8051 microcontroller. This is for 10 marks. So first you have to write the diagram of the architecture of 8051. So here is the diagram of 8051 architecture, and you have to provide description for this architecture. So that's what explain the architectural features. So you have to provide the proper description for this diagram. So that totally covers for 10 marks. 1C, explain first one RST, second one INT pins of 8051. So this is for 4 marks. So RST pin, so it is an input and active high pin. Upon applying high pulse to this pin, the microcontroller will reset and terminate all the activities, and this is pin number 9. And then for INT, so INT stands for interrupt pins. So there are two interrupt pins available, that is INT 0, INT 1. You have to mention that. If you can remember, mention the pin numbers, and also you mention in which port it is available, which port pin it belongs to. So this covers 4 marks. Question 2a, differentiate between CISC and RISC. So again, it's a differentiation between two concepts. So there are so many differences I have just listed over here. So among all these, at least you have to mention 5 clear differences. If you mention 6 differences, then it will be much better. At least you mention 5 differences among these. Then 2b, with neat diagram, explain the internal memory structure and programming model of 8051 microcontroller for 10 marks. So here I'm just providing you the programming model. So you have to write this block diagram, and you have to briefly describe about how these buses are interconnected and how these things are going to interconnect and they are going to communicate with each other. So brief description of this diagram is required. So this is about programming model. Getting into the memory concept, internal memory concept. This is what the internal memory concept. So in the internal memory, you are going to have both ROM as well as the RAM memory organization. First, you have to take the ROM representation. So for ROM, you make use of the internal memory, as well as we can also access the external ROM. So option for both of these two are presented over here, and they are enabled by making use of EA pin of 8051. If EA is equal to 1, so it is going to make use of the internal RAM, that is 4 KB capacity memory starting from 0000H up to 0FFH. So in continuation, so the program counter automatically shifts to the next continuation memory location. So that memory location continues from 1000H up to FFH. So this part is going to be external and this part is going to be internal. If 100% we are making use of the external memory, then set EA pin to 0. then 100% external memory we will be making use of, that will be from 0000H to FFFFH. So this is about ROM memory location. Similarly, we have to also address the RAM memory location. So RAM memory location, so here is the details. So it starts from 00 to 7FH. Total 128 bytes we are going to have. This 128 bytes is divided into three parts. So first part is this one, that is from 00 to 1FH. So it consists of 4 register banks. Continuation 20H to 2FH. So this is another set where all these are bit addressable. Continuation 30H to 7FH is general purpose RAM memory location. So you have to make a brief explanation along with this diagram. To see, list out special features of 8051 microcontroller. So this is for 4 marks. So 8051 is having list of special features available. So among these features, still there is a continuation of this. Among these features, at least you mention 8 of this. So this is one set continuation. This is the continuation of that. So at least of so many features, you must mention 8 features. If you mention 9 to 10, that will be always appreciated. Now getting into the module 2, and let us go through the examination questions of it. Question 3A, define addressing mode. Explain different addressing modes with example. This is for 10 marks. Now the definition for that first, the way in which the operand of an instruction is specified is called addressing mode. This is the definition, right? Then after second part of the question, we have to explain different addressing modes. So these are the various addressing modes available within 8051. So mention all of this or list it out first. Then one by one, you just write at least 2 to 3 sentences about each of the addressing modes, and never forget to mention an example for that. Without example, it is not possible to have a complete explanation of that addressing mode. Therefore, during the explanation of these addressing modes, never forget to mention an example for that. Then 3B, write an ALP to add two 16-bit numbers loaded in R1, R0 and R3, R2. Store the result in R6, R5 and R7 from MSB to LSB. So now here there is a clear mention that R6 must hold the MSB and R4 must hold the LSB of the result. Now let us have consideration of what data we are going to have so that it will be much clear for us while writing the program. So the first data is available in R1, R0. So here it is being considered that R1 holds the MSB 8-bit, R0 holds the LSB 8-bit, combination 16-bit, and the value we are considering is 22 and 2211 is the data 1. Similarly, R3, R2, this 44, 33 is what data 2 we are considering. Now adding these two 16-bit, the answer is going to be 6644, and final R6 will hold the value 0 in this particular case. Right? So let us make a follow-up of the same data within the same presented register, and program is given over here. So first part of the program, that means up to this part, is for the initialization. So this is first 2 lines data 1, second 2 lines data 2, and then we are initializing R6 to 00. Then after we are taking the first value R0 to A. So here we cannot add 16-bit data directly. We have to first take two 8-bit data, add them, then take remaining two 8-bit data, then we have to perform the addition operation. So first what we are doing is R0 plus R2 we are performing. So for that first value R0 we are taking that to A, that is being added with R2, result will be available in the A register. In case any carry generated, that will be available for us in the carry flag. Then after, we are storing the contents of the A to R4. So first LSP 8-bit to the register R4 we are storing. Then after, add the contents of R1 and R3. So take contents of R1 to accumulator, add that content with carry because there is always a chance that there may be a carry generation after the addition of R0 and R2. Therefore, here we are going to use add with carry instruction and add that with accumulator, and R3 contents will be, the result will be stored to the accumulator. Now store the contents of that accumulator to R5, that is second part of the summation is stored into the register R5. In case if carry generated after the addition of R1 and R3, that must be stored to the R6. Therefore, we are verifying for that carry is generated or not. If carry is not generated, then go to the label down. If carry has been already generated, then we need to increment R6. So that's what the program we are going to have for this one. So in this case, you take an example like this at one side and then you write the program. That will be very much helpful. Now the question number 4a, define stack. Explain the operation of stack using stack pointer, push and pop instructions. This is for 10 marks. First, the definition. Stack is a temporary storage area within the internal RAM. Right? Definition is over. Then we have to make an explanation of the stack using stack pointer, push and pop instructions. So this is what some of the theory related to the stack pointer. What is this stack pointer? So what is the purpose of the stack pointer? Then what are the instructions related to the stack operation, and what is the meaning of push and pop? So some of the definition, some of the related explanation is given over here. So along with this, we have to clearly make an explanation that how stack pointer is going to work and push and pop instructions are going to work with necessary example, because it is asked for 10 marks. We have to look into that one. So here is the illustration. So an example has been taken over here. A small program has been taken. So in this, 3 registers are being used, R6, R1 and R4. First the push operation is being performed, then the pop operation is being performed. Right? So how this is going to work in the stack, on stack, that has to be illustrated through this diagram. Right? Now this diagram is going to illustrate what is the position of stack pointer. By default, power on reset. Then after, where the first value will be stored, that is push R6, where it will be stored, and then second value, then third value, how it looks like. During the pop operation, what is going to happen, how each data will be fetched out, so that will be represented. So this illustration with this example with necessary explanation will fetch you the complete marks. Question 4b. Write an ALP to find largest of n numbers. This is for 10 marks. So we can consider the same program what we are going to do in the lab. You can write the same program over here, or you can just refer to the program that is presented over here. So after writing this program, it is good to show the result of the program. So take an array of values and and which is the largest value from that, you need to mention that, and it's the similar representation that before execution and after execution, what will be the output. If you mention it clearly, then that will be much appreciated. We will again join with the remaining modules in the next session. Thanks for joining.